So the main difference between 6.4 and 6.5 is that this section is talking about using non-spontaneous redox reactions. And we have to drive them with electricity in order to get them to go. So we're actually going to be forcing electrons on the SRP table from the top to the bottom. So we're going in the opposite direction. And anytime you've got a solution of something that conducts electricity, that substance is known as an electrolyte. And whenever we put electricity through an electrolyte solution, this process is called electrolysis, and the apparatus that we use is an electrolytic cell. So last section was electrochemical cells. This section is electrolytic cells, okay? And let's take a look at the next page. And here, the oxidation half reaction where is it on here? The oxidation half reaction will be at the top of the SRP table. So the one that loses electrons is at the top, the one that gains electrons is at the bottom. And then here you're going to notice that we are in one compartment. So oxidation still occurs at the anode in electrolytic cells, and reduction occurs at the cathode. But the only difference is that, do you see how I don't have two separate compartments? Everything is in one. Okay. And then this little symbol at the top of the figure right here, that indicates that we are using electricity to make this happen. Okay. So, electrochemical cells make electricity. Electrolytic cells use electricity. And then the oxidation half reaction is above the reduction half reaction. So let's turn to the next page. And is there only one set of practice problems in here? No, it's two. Okay. All right. Okay. So here I've got two half reactions. If you take a look at their location on the SRP table, which one's at the top and which one's at the bottom?
One silver is higher.
Okay, so if this one's at the top of the SRP table, that means it will give electrons to something else. So the electrons will flow in this direction, and then this is at the bottom. All right, so the half reactions are already in the order that we need them to be. So if we take our silver, and we're going to have to multiply it, since you have two electrons in this half reaction, you're going to have to multiply this half reaction by 2, so the electrons match. We also need to write down what their voltages are. So in the table, it says that silver is it's negative 0.80, yeah, because it was flipped. So you have to flip the sign And then your nickel is negative 0.26. Now, something that you should be aware of is even if you multiply a half reaction by a coefficient, you do not multiply the voltage. The voltage would stay the same, okay? So now you can add these two together. This gives you the overall reaction. And the cell comes out to be a negative 1.06 voltage. So the electrochemical cells that we have in the previous section had positive voltages because they were spontaneous. Here they are negative because they are non-spontaneous. I'm going to turn that on. Do not touch that graduated cylinder. That has 16 more nitric acid. Okay, so I haven't just figured out how I'm going to neutralize that other than the my phone. So, okay. All right, so yeah, all those solutions in the middle there, except leave the blue solution with the copper ions in it in that volumetric flask. Because that I'm using.
I need something.
I've got nothing. This entire container can go in Brian's thing. In fact, you could even carry it with.
Oh, you want me to pour the stuff into a plastic bag?
Yeah.
Oh, okay. I thought you meant pour it into the beaker and then cover it with the plastic.
Okay. All right. So here's what this means. If you had to explain to something how to get this to go because it's non-spontaneous, this is the minimum amount of voltage that you would need to get it to go. So what you would say is a voltage of at least 1.06 would be required to operate this cell. Now, this is theoretical. Like, in the real world, we might need something else, okay? So, and that's called overpotential. When you calculate it versus when you go and do the experiment, it may be slightly different, okay? All right. Is this pretty straightforward, easy? Okay. All right. So then let's take a look at, this is a summary page. So this summarizes everything about electrochemical and electrolytic cells. It's actually really helpful. So the left-hand side is your electrochemical and the right is your electrolytic. The left side says we release heat in electrochemical cells. It makes us electricity. We've got two compartments. It uses the spontaneous redox reaction. The E that you calculate is positive. I use a salt bridge. And then they give you an example of what it would look like, okay? And then the oxidation half reaction is below the reduction half reaction in the SRP table, so the electrons move upwards. Electrolytic cells, they absorb heat energy. They're taking electricity. They are one compartment. We use a non-spontaneous redox reaction. That's why your E is negative. There's no salt bridge because I don't have to connect two compartments. The oxidation half reaction is above the reduction half reaction on the SRP table. Okay. Okay, now, next page. There are a lot of different electrolytic cell types. I don't test you on them. Okay, it's not really relevant. They're just here for extra information. And then over here, they start talking about what the applications are. Again, I don't really discuss any of this on tests. So if you're coating a metal with something else, that's electroplating. And then if we turn to the next page, that's pretty much it. There's not really anything else that's really relevant for you. Okay?